All right, welcome to lesson 2 of week 2 of quarter 4. So today we're going to talk multiplying rational expressions. And there's a really simple way to think about multiplying rational expressions. We're going to do exactly what we did in the first lesson this week on simplifying rational expressions. We're going to do it twice, and then we're going to multiply. So if you thought the last lesson was a little bit of work, wait for this one. Okay, so we'll warm up here. What I want you to do in this warm up, and you could try this on your own. You could like pause the video and say, okay, I'm going to read through this and do this, and then restart the video. But I'm going to do it right now. So if you want to do it, you better pause it now. So what we're going to do is find the product of the two fractions that we have here. And you'll see I've got it listed twice, and that's because on the top one, I want you to multiply the numbers that you see and then simplify. But on the bottom one, what it wants you to do is eliminate common factors first and then multiply what is left. Okay, and there's a little note there. It says it is okay to eliminate common factors from different fractions when multiplying. All right, and what I mean by that is if you've got a numerator in one fraction that has a 2 in it and a denominator in the other one that has a 2 in it, well, you can eliminate those 2's even though they're in separate fractions. And you'll see what I mean in a second here. All right, so the first one, though, we are going to just straight multiply across, and then we're going to simplify. So we multiply across. 4 times 6 is 24, and 9 times 5 is 45. And you can see right away that maybe this isn't the best approach, because now we have 24 over 45. And I know some of you are tempted to grab a calculator, but don't. Put it down. We don't want to use a calculator, because this is going to be some wacky number that doesn't work. We're going to have to round. What we have to do now is we have to say, all right, well, what's a common factor between 24 and 45 that we could eliminate? I mean, we could make a list, I suppose. Let's do that. Let's make a little list. I'm going to do it up here. So 24. 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6. All right, that's all of them. Trust me, it is. Now I have to look at that and say, which is the largest one that goes into 45 evenly? Well, it's not 24. It's not 12. It's not 8. It's not 6. I can eliminate the even ones because 45 is odd. It's not 4. That means it's not 2 either, and we don't want 1, so that just leaves us to 3. So we have to go all the way down to 3 to figure out the common factor. All right, so I'm going to simplify this now by writing it as 3 times 8 and 3 times 15. And I cancel the common factor, and I end up with 8 over 15. Whew. Too much thinking. Now, 8 over 15 is simplified because 8 and 15 don't have any common factors. Okay? And if you doubt that, just make a list for 8. You'll see. All right, now on the second one, what I'm going to do, instead of multiplying right away, is I'm going to rewrite these things. I'm going to factor what I can. So 4, I mean, you have to kind of be a little selective, right? In what you're going to factor. I don't even really need to factor the 4, and you'll see right away what I mean. But the 9, notice there's a 9 and a 6. They have a common factor, and it happens to be that 3 from up above. So I can rewrite this as 3 times 3, and I can write this one as 2 times 3, and I'm just going to write that as 5. So I didn't factor everything because I don't have to. Now, if you did factor everything, that'd be perfectly fine, but it's just going to create a little extra work. Okay, so I'm going to eliminate a common factor. Now, this is where my note from above, there's a 3 in the denominator of the first fraction. There's a 3 in the numerator of the second fraction. I can eliminate the 3 from the numerator and one of the 3's from the denominator. And now I can multiply across. 4 times 2 is 8. 3 times 5 is 15. Okay, hopefully you found that the second method is easier, because that's going to be the process that I want you to try to follow for multiplying rational expressions. With rational expressions, it gets crazy if you try to do the top method. You end up with some really wacky stuff that's hard to factor. So you really should follow the second method for multiplying rational expressions. Okay? So what's it say here? It says multiplying rational expressions usually leads to a new rational expression that needs to be simplified. To make the process of multiplying rational expressions easier, always factor, eliminate common factors, then multiply what is left. Just like we did above. We factored, we eliminated common factors, and then we multiplied what is left. Okay? All right. So these get a little trickier, though, because we have variables involved. And I think we should go ahead. How do we want to do this? So the numbers are kind of the hard part on some of these, but the variables we could do multiple different ways. And I guess it kind of depends on you, what you prefer, but here's what I'm going to do. I'm going to rewrite this as -1 times 7, and then an x over 5y times 3y to the 5th over 2 times 7x squared. Now, there's multiple ways we could do this, but let's do it this way. So I'm going to eliminate the 7 now because that's a common factor. And if I rewrite this thing, now I have -1x times 3y to the 5th, and then this one's over 5y, and this one's over 2x squared. Okay, so now I'm just going to multiply across. I don't want to run out of room here. Where am I going? All right. So I have -1 times 3 is -3, and then we have x, y to the 5th, and then 5 times 2 is 10, and then we have x squared y. So notice I put it in the alphabetical order. And now, I kind of like to do it this way because it's easy to get kind of lost if we try to cancel variables the other way. Now, I suppose you could write them out where the x squared becomes x times x, and the y to the 5th becomes y times y times y times y times y, but then that ends up being a little bit much. But we, you know what? We've got space. We'll do it both ways. So now, if I eliminate x's, or if I apply the division rule for exponents, I'm going to end up with -3 y to the 4th, because I have y to the 5th over y to the 1. I subtract 1 from the 5. And then it's all over 10x, because I have x to the 1 on top, x squared on the bottom. 2 minus 1 is 1, so it stays in the denominator. So this is the product of those two rational expressions. Okay, so it really got simplified quite a bit because the numbers are much less complex. Okay, let's do this again here, though. So I'm going to go to the right here and say, all right, this is -1x over 5y times 3, and then I'm going to write 5y's. Now, if you like this method better, by all means, use it. Okay, so I just expanded all of those exponents, and I'm going to go in with a different color to eliminate. So I can eliminate an x and an x, a y and a y, and now I can just write what's left. I can multiply what's left. So -1 times 3 is -3, and I have y to the 4th because there's 4 y's there. And then I have 5 times 2 is 10, and I have 1x. And you can see that we got the same answer. So whatever path you prefer, if you like the one that just went straight across, that's perfectly fine, where you write everything out. It can get a little tricky if you get a lot of big exponents, but as long as they're smaller exponents, it's not too bad. Or you could go down like we did and apply the division rule. You just have to remember, if the exponent's bigger, that's where it's going to end up staying. So, all right, let's do another one. Okay, so this one. Sometimes you can multiply right away, and it actually isn't too bad. This one wouldn't be too bad if you decided to multiply right away, but I like to simplify if we can. This one, so this one's interesting because I don't necessarily have to do anything to the 6 or the 5. Because there's going to be stuff left. I don't need to do the 1 times 6 thing or the 1 times 5. But the bottom I can do 2 times 5x squared. And then this one would be 2 times 6. And I'm doing this because I noticed something. I noticed that there's a 6 on the top. I noticed that there's a 5 on the top. So that's why I'm factoring it into those numbers. You could do different numbers, like 12 you could have done 3 and 4, but you wouldn't get all of the numbers you want to eliminate. So we're going to eliminate, I'll change colors again, I like that. 6, 5, so then we're left with, we have x to the third and x on the numerator. So when we multiply those two, that becomes x to the fourth. In the denominator, we have 2 times 2 is 4, and then we have x squared. And then if we apply the exponent rule, the division rule, we subtract, and we're going to subtract where the bigger exponent is. So 4 minus 2 is 2, so this is x squared up here, over 4. There we go. That wasn't too bad. Now this one you could just multiply across. 6 times 5 is 30, 10 times 12 is 120. And then do a little division, you'd see that that becomes a 4 on the bottom. But, you know, I would suggest always factoring first, eliminating factors, and then multiplying what's left. All right, this one. So, like I said on the last one, I noticed something. I noticed something that I could factor and be able to eliminate. In this case, I'm noticing something. There's nothing that I can factor and eliminate because 25 can't be divided by 2, and the 1, well, that's just a 1. So what I'm going to do is just go ahead and multiply first. So the numerator becomes 25x because we're multiplying by 1, and the denominator is 2y to the third. And that's it. We're done. That was too easy. All right. Now, don't be tempted to divide 25 by 2. You'll get a decimal, and we don't want that. All right, here we go, another one. Okay, so this proved a little tricky on the domain, finding the domain of rational functions. Some people were like, ooh, what do I do? What do I do? Whenever we have something that has a common factor like an x, we can factor the x out. So I'm going to go ahead and do that. So we have x times x minus 1 over 5x. There's nothing I can do with that 5, so I'm just going to leave it like that. And then times, and because there's a 5 down there, I'm going to factor the 15 and do 5 times 3. And, oh, I need more space. That denominator, and this is going to be one that catches people off guard, x squared minus 1. It's the difference of squares. So I can factor it into x plus 1, x minus 1. Okay, so I got a lot of canceling to do here, so I'm going to cancel a x minus 1 and an x minus 1, a 5, and a 5. And in this one, since the x in the numerator and the denominator is just a single x, I can actually eliminate that as well. And you'll see I was crossing over from one fraction to the other. The 5s were in different fractions. The x minus 1 were in different fractions. That's perfectly fine. As long as it's multiplication, we can do that. If this symbol in here was plus or minus, we could not eliminate from different fractions. Okay, so we end up with, the numerator boils down to just 3. And then the denominator is just x plus 1. That's it. I made an awfully big fraction bar there. All right. Is that it? Oh no, there's more. Holy smokes, this is going to be a long video. All right, there's 2. And they're huge. All right. Lots of factoring. Lots of factoring here. You're going to be like, great. Just what I wanted to hear. I might work my way down here and then over if I need to. All right, numerator of the first one, 3 times x plus 1. Okay, again, just like in the previous video where we were simplifying, if you get a binomial like x plus 1, you might want to try and find that binomial somewhere else. All right, and this bottom one. I'm sighing because of what I saw. Here we go. 1 minus x. Yikes. That's not what we want, but we'll fix it. We can do what we did before. Okay, so then the denominator, or sorry, the numerator of the other one is going to have binomials in it. Okay, so then we have 2x and 1x, because 2x times 1x is 2x squared. And then we have negative 3, so we know we have to have a 3 and a 1. And I'm going to put the 3 here and make it plus, and the 1 here and make it minus. And it works because 2x times negative 1 is negative 2x. And 3 times 1x is positive 3x. We add those together, we get positive x. And that's what we want. And then the, this is another good one, because look at this thing right here. I'm going to bet that that's going to show up in the bottom here. So if we just write a 2x plus 3, it's the difference of squares. 4x squared is a perfect square. 9 is a perfect square. There's subtraction. So it's 2x plus 3 times 2x minus 3. And you might be thinking, man, how do you do this so fast? Well, I've seen it a lot. I know, I just recognize something when I see it. And that's really what I hope that you guys can eventually do. So here we go. We got common factor there and there. But then this one is throwing us off. And I'm going to do a little work here and then erase and rewrite. All right. So I'm going to do a little work for this, not with that. With that guy right there. So I can take this and I can flip it around and make it that. And then if you remember from before, we can factor out a negative now. And we get negative 1 times x minus 1. Well, that doesn't help us because that's an x plus 1 up over there. But if we look over here, those two are now going to be the same. Even though there's that 1 in there, I can go ahead and put a 1 in here if I want. They end up being the same. So I'm going to rewrite this as, oh, yeah, shoot, negative 1 times x minus 1. All right, this one gets a little tricky, a little messy, but it's like, it is what it is, right? Okay, so then that, so I'm highlighting the things that are the same, and you'll notice there's nothing else that's the same. And there's one little weird thing that we have to do, but I'm going to erase this, and we're going to go back up here, and we're going to say, all right, I can eliminate, I can eliminate that, and that, and that, and that. So now I have, in the numerator, it's going to be 3 times x plus 1. And the denominator is where things get interesting, because 5x times negative 1 becomes negative 5x times 2x minus 3. Oof. That was a handful. All right. So I went through that pretty fast. I recognize some stuff. Again, you can stop the video. You can go back. You can look at stuff again. You'd be like, what did he do there? And if you don't understand something that I did, let me know. Come to my office hours, 9 to 10, Monday through Friday, a.m., not p.m., or by appointment on Friday, anytime. Okay, we got another one, just like the other one. Cheerleaders in high school, they used to say that. Here we go. What I'm going to do first here. Since this thing is out of order, I'm going to write it in the right order. That way it might save us a little headache here. Oh, this one's not in the right order either, so let's rearrange that one too. So anytime they're not in the right order, I would rearrange them, because then when you factor something, you can see, oh, I see, I can take a -3 out of the numerator of that fraction. Okay, so I'm going to factor out a -3, and it becomes x minus 2. And that way you don't have to do what we did in the last problem, where it's like, oh, we got to stop, we got to flip it around, we got to mess around with it a little bit. Okay, and then the denominator, I can take a 6x out of that. So this becomes x plus 1. So none of that really, well, I guess there is some. We could then factor that 6 a little bit, but we'll get to that in a minute. All right. We don't want to get too far ahead of ourselves. So the denominator of the other one, perfect square, subtraction, so that's difference of squares. So that's x plus 2, x minus 2. And then the numerator is a fairly simple one to factor, because the 3 only has one set of factors and the 5 only has one set of factors. So this is going to be 3x and x. And now we have a 5, it's negative, so we need to put a 5 and a 1 in there somewhere. If we put the 5 in the right-hand side, it's going to be 3 times 5 is 15, which is too big, so we're going to put the 5 here and the 1 here. And then since it's a -2, I'm going to make that negative and that positive. Okay, so sometimes, you know, we get to a point like this, and it's like I mentioned something about the 6. We need to kind of rethink the 6 a little bit. We can factor that. Actually, we need to rethink the 3 and the -3 and the 6. So what I'm going to do is I'm going to erase the -3, erase that 6x. I'm going to rewrite the x though. So I'm going to write this as 3 times 2, and that -3 is going to become 3 times -1. Okay, so that was what I was kind of getting at. And, you know, if you don't see that right away, that's okay. You can catch that on the next step. You wouldn't have to do it all right now. So I'm going to go ahead and eliminate. I can eliminate the 3's. The x minus 2 with the x minus 2, the x plus 1 with the x plus 1. And so you can see I've got some stuff left, and maybe we could highlight what's left. So we've got that, and those two things, and that thing. So the -1, it just makes that binomial negative. So I'm going to write it like this, -3x minus 5. So that's my numerator. And then 2x times x plus 2. And that's it. You're like, yeah, right. That was a lot. It is a lot, but if you just take your time, and, you know, I'm doing it all at once here. I mean, you could have, I did 1, 2, 3 rows basically to figure this out. Well, if you have to do 6 or 7 or 8 or 9, you know, that's totally okay. You know, eliminate a little bit and then be like, oh, wait a minute, I can maybe do some more, you know. That's totally fine. All right, again, just like in the past, those challenge problems down at the bottom, these are really good problems to help you think a little bit more instead of just do this type of work, okay? All right,